Section 5.2 on page 119 of your notes packets is proving trigonometric identities. So some general strategies that some may be applied to proofs, but they don't all have to be applied to each proof. The first is the proof begins with the expression on one side of the identity. Second, that the proof ends with the expression on the other side of the identity. So in general, we only want to be editing or proving, manipulating one side of the identity. Number three, the proof in between consists of showing a sequence of expressions, each one easily seen to be equivalent to its preceding expression. Number four, begin with the more complicated expression and work toward the less complicated expression. Number five, if no other move suggests itself, convert the entire expression to one involving sines and cosines. We saw this in a previous section. And number six, combine fractions by combining them over a common denominator. So let's see what this looks like put into action. All right, so with example one, we'll start with the tangent of x plus cotangent of x. So I'm going to rewrite that here. Tangent of x plus cotangent of x. And the first thing I'm going to do is rewrite these using their quotient identities. So tangent of x, remember, was sine of x divided by cosine of x, plus cotangent of x, which is cosine of x divided by sine of x. And this is the quotient identities. And then I'm going to rewrite these. So now I have two fractions with different denominators. So I'm going to rewrite these with a common denominator. And the common denominator that I'll use is cosine of x times sine of x. That's our least common denominator. In the numerator, we'll have sine squared x plus cosine squared x. This is multiplication to find a common denominator. All right, our next step is to notice that sine squared of x plus cosine squared of x is equal to 1. So I can rewrite this as 1 divided by cosine of x sine of x. And that is the Pythagorean identity. And then this is just multiplication, so I could say this is 1 over cosine of x times 1 over sine of x by multiplication, which equals secant of x times cosecant of x by the reciprocal identity. Once the final statement matches the side of the equation or the identity that was not manipulated, the proof is complete. So now that we've gotten down to a statement that says secant of x times cosecant of x, which matches our other side, I know that these two sides of the equation are indeed equivalent. Go ahead and try using those 6 strategies to complete example 2, and then reflect on those strategies in the 2 examples, and on the next page, summarize what you learned.